In this section, we'll be taking a look at the configuring and monitoring BGP Layer 2 VPNs objective of the JNCIP SP exam. For more detailed coverage of this topic, please check out the Juniper courses AJSPR, JL2V, and JL3V. In this video, we're going to take a look at BGP signaled Layer 2 VPNs. And to demonstrate this concept, we're using this network here. We have a service provider portion that's using RSVP signaling for LSP generation, and we have a full mesh of IBGP sessions running between our PEs, particularly PEs of note R1, R2, and R6. And over this IBGP and RSVP mesh, we're signaling a full mesh of virtual circuits between XR1, XR2, and XR3, illustrated by these dotted red lines here. And for the bulk of this video, we'll focus on the configuration of PE R1. We'll take a look at the different elements of configuration that are required to deploy a BGP signaled Layer 2 VPN. So let's log on to R1 now and take a look. First thing to note here is that this is multi-protocol IBGP because we have multiple address families configured. The one that we need for our purposes is family Layer 2 VPN signaling. This is going to be advertising our site identifier and various MPLS label information to remote PEs to allow the establishment of our virtual connections to our remote sites. To go along with our multi-protocol IBGP configuration, we then configure our Layer 2 VPN routing instance. And as you can see, there are quite a few similarities between a Layer 2 VPN and a Layer 3 VPN. Let's walk through some of these configuration elements. So we're configuring our routing instance with a specified name. You'll notice the instance type is different from Layer 3 VPNs, where that would be VRF. Here we're saying Layer 2 VPN. We then specify the local interfaces to which our CEs are interconnected. We take a look at an actual CE interface configuration. This is also important to note. We're deploying emulated Ethernet VLANs, so we're specifying encapsulation VLAN CCC. If we were just deploying pure Ethernet virtual connections, the encapsulation would be just pure CCC. And we specify a VLAN ID, much like you would with a vanilla 802.1q environment. A key thing to note here is that this configuration goes along with the VLAN tagging configuration on the parent physical interface. When you're configuring Layer 2 VPNs, you have to start your VLAN numbering from 512. If you wanted to start your VLAN numbering from VLAN 1, you would have to use extended VLAN tagging. So that's our local CE-facing interfaces. We then also specify a route distinguisher to make our routes unique, and we specify a route target to control route import and export from our configured VPN. Then we configure protocols Layer 2 VPN. Here we're specifying encapsulation type is Ethernet VLAN. This is going on in conjunction with the VLAN CCC encapsulation deployed on the PE-CE interface. And we specify our local sites. Each local site is given a human readable name and a site identifier that is unique within the configured VPN. And then underneath this site, we are then binding our local CE-facing interfaces to remote site identifiers. So this binding of local interface to remote site ID is what creates our virtual connections. and we have two local interfaces and two remote sites. So we have two virtual connections in the case of the VPN from the context of this PE. And this configuration here, we're explicitly configuring our remote site identifiers. We can configure things in a slightly different way. We can make the assignment of remote site ID implicit. And to illustrate this concept, I've used that configuration style on one of the remote PEs on router 6. Here you see the configuration for the local site is slightly different. Again, we've given the local site a per VPN unique site ID, but now we're only listing the local CE facing interfaces. We have not specified an explicit remote site ID. So in this style of configuration, the remote site ID is assigned automatically, and it's assigned based on the order in which these interfaces are applied in configuration. So this would be remote site ID 1, this would be 2, and so on. If we had a third interface, we would skip the local ID of 3, and we would move on to 4, and then 5 and 6, and so on. This style of configuration is particularly useful when your given VPN contains many different remote sites, and there is a high degree of meshing between those sites, because it minimizes the amount of configuration required to deploy the connections between those sites. So this was a summary of the configuration elements that you need to deploy a Layer 2 VPN. In the next video, we'll take a look at the operation of this VPN. In this video, we're going to take a look at the operation of BGP signaled Layer 2 VPNs. And to demonstrate this, we turn again to our network as shown on the screen. We've got our 3 customer sites with XR1, XR2, and XR3 CEs interconnected to our service provider that's providing virtual connections between these 3 sites. And these virtual connections are signaled using IBGP in the service provider running on top of RSVP signaled LSPs. So let's now dive in and take a look at the current state of the network from the perspective of R1. So obviously we're using BGP for signaling, so we're going to take a look at some of the information that's being advertised via BGP. First thing to note is that in a Show BGP summary, we're now seeing routes from our Layer 2 VPN address family associated with the BGP Layer 2 VPN routing table, and from there they're going to be propagated into the customer specific Layer 2 VPN table. Let's have a look at this table and see what routing information is contained within it. So already you'll notice the similarities with the BGP L3 VPN table. We have our routes contained within it that have the route distinguisher appended to them to give them uniqueness. The main obvious difference is that we're talking about layer 2 routing information rather than layer 3. So instead of IP networks, what we have described are remote site IDs. You can see here that this is describing the remote site ID 2 and the remote site ID 3. There is also a lot of other information carried within these routes. Let's have a look at that now and see how that relates to signaling our virtual connections. Let's take a look at the route that we've received from site 2 that's interconnected to PE2. We can tell that because the source of the IBGP route is the loopback address of router 2. And let's first have a look at the BGP communities that are associated with this route. The first one you recognize as a route target. This is controlling what VPNs this route is going to be imported into. Next, we have a layer 2 VPN specific community called layer 2 information. And this contains additional information about that emulated virtual connection. It's telling us the circuit is using Ethernet VLAN encapsulation, and in the control flags portion, it's telling us that we're using a control word. So we have that additional control word encapsulation, and this can also be used to discover configured remote MTUs so that we can prevent circuits coming up between sites that have an MTU mismatch. As well as carrying information in associated communities, we also have information advertised within the NLRI itself. And this is showing us things like the base MPLS label, the label range, and the label offset that in combination with the site identifier, we can use to calculate the label that will be imposed on traffic that we send to remote devices, and the label that will be present on traffic that's received from remote devices, so that we can forward traffic for this virtual connection. And finally, another piece of information to mention is that also in the NLRI, we have the circuit status vector. And this is going to indicate if any remote interfaces on this PE that are associated with this VPN are down. And we can use this to track the operational status of the different virtual connections that make up our layer 2 VPN. Information from this field is used to propagate this really useful operational command, which is the show layer 2 VPN connections command. This is going to list all of the current connections associated with particular VPNs. And it's going to tell us various pieces of operational state regarding these virtual connections. You can see that we have two connections here. There's one and there's the second. It's telling us things like the site ID, the remote PE IP address, and importantly, the operational status of these virtual connections. It's also telling us things like the expected incoming and used outgoing label values. This status value is going to change if these circuits go down, and you can use this crib sheet at the top of the output to associate specified error messages with specified error conditions. And that's very useful in troubleshooting the different reasons that could be causing virtual connections to not operate correctly. If you execute this command with the extensive flag, you will also get a history of the operational status of all of the listed virtual connections. That's how you troubleshoot the control plane for layer 2 VPNs. Troubleshooting the data plane is very difficult. It's not possible to run things like pings on the PEs to inject traffic into those virtual connections and test data plane connectivity. It's also not possible to check things like the MAC learning table as you would on a real switch. This is because with virtual connections in layer 2 VPNs, all traffic on those connections is forwarded. We're not performing any MAC learning at all. There are a few things that you can do to troubleshoot the data plane. You could have a look at the interface counters on the CE facing interfaces. So we have a very small packet count at the moment. What if we hop on to the connected CE and generate some traffic flowing over that virtual connection? We can ping the remote IP address, for example. Now you can see the packet count is incrementing on that interface. so you know that traffic is traversing that interface. So obviously, if you can get cooperative involvement from the customer to run tests on the CE, that is a good way to test connectivity. What if we break a virtual circuit? Let's see how the operational output changes. So if we jump onto the remote PE for this circuit, which is R2 in this case, let's disable the interface. So this has now broken that virtual connection. What's happened to our ping on the CE? You can see that it's stopped. So we definitely have broken the data plane. We now turn back to our PE. We run our show layer 2 VPN connections command again. You can see that the output has changed. What we now have is status virtual connection down. We go up to the crib sheet at the top. It's telling us the virtual connection, the virtual circuit is down. And if there was another cause that was happening here, other than say the remote CE interface being disabled, you can cross-reference to this table. This is a quick overview of the operation of layer 2 VPNs.